All right, welcome back. This is lesson 2. We're going to play with some basic instructions, mainly just no-op, increment, and decrement. First thing I'm going to do is reset the board. So if I hit the reset button, it will reset the program counter to 0. It will clear out the internal registers, but it doesn't change memory. I can see location 0 still has a 123. If I hit reset twice, it will bring up a menu and say, hey, if you want to erase all memory, go ahead and press a 1. If I do that, memory gets erased, and now location 0 and all other locations have zeros in them. Alright, when we examine memory, normally we're just looking at memory locations, but there's some special registers that we can address. If we look at memory locations 400 through 407, we're not actually looking at the memory itself, we're looking at these internal registers, R0 through R7. They're like memory locations, but they're easier to access because they can be operands for things like increment, decrement, add and subtract, and so on. So they're faster access, basically. So we have 8 general purpose registers, R0 through R7. We have the program counter, which says which instruction we're going to access, and some other things we'll talk about later. So if I want to look at a register, I can examine and address 400 through 407. I can also change my registers like that. So I want to play with this increment instruction. Increment is coded as a 1 followed by a 0 followed by a register number. So if I were to store at location 0 the number 100, so we'll deposit that, and then we can go back and examine 0, 0, 0. We see it's the instruction increment R0. Alright, so let's take a look at location 400. So I'm going to type 400 examine, and you can see it tells me R0 is all zeros. And if I hit examine again, it will show me R1, R2, R3, and so on. So it will show me consecutive locations. So let's go back to program counter address 0, and let's just step one instruction which says increment R0. I'm going to say step. Alright, nothing much happened here, but if I were to go back and examine location 400, I can see now it says R0 is equal to 0, 0, 1. It added 1 to R0. Alright, if I go back to location 0, that's my increment R0. Let's do some more increments. So I'm going to deposit a 100 here, but I'm going to deposit that also in successive locations. And so I've got a number of increment instructions stored. Let's go back and look at location 0, and you can see all of these instructions are stored. So let's reset the program counter and let's step through these instructions. So I've just done several increment instructions, and now if I look at location 400, I can see R0 is equal to 6. If I step again and I examine location 400, R0 is equal to 7. So we've got a program in our computer's memory. It's a program which says increment R0, and just do that several times, after which it will just go back to executing no-ops. Alright, so not the most complex program in the world, but a simple illustration of successive instructions being executed to modify the contents of memory. Let's do one more. Let's look at a decrement instruction. So decrement is coded as 1, 1 followed by a register. Let's decrement register 4. So I'll go back to location 0, and I'll say 1, 1, 4, and deposit that. And let's do a few decrements. Alright, so that's going to decrement register 4. Let's go back and look at 404, and it's got a 0 in it by default. So let me reset the CPU and do a step, and now if I look at 404, it's 377. Now why is it 377? Because it was 0 and we subtracted 1. That's what decrement does. which meant, we want a -1, but we don't have a -1, so it rolled over and it gave us the biggest number it knows, which is 377. If I step again and I examine 404, it's 376. If I step again and I examine, it's 375. So it's decrementing this register as we go. Alright, so that's a simple example of a few instructions, increment and decrement, and also looking at some register values. To make this more interesting, we need a way to tell the system to start executing instructions more than once. And so this is going to bring in the concept of a loop. So we'll go ahead and do that in the next lesson.